Okay, so periodic graphs and amplitude. All right, so we're going to look at two things here. We're going to look at basically changing vertical stretches and compressions and horizontal stretches and compressions. So a lot of your functions that we see going to look like this. And so those are ones that we need to be able to work with. So in this section and the next, the graphs of such functions will be analyzed. All these functions are periodic, and their graph consists of series of identical waves. A single wave of the graph is called a cycle. So when we graph from negative 2 pi to 2 pi, we're actually graphing two cycles of sine and cosine, right? Because one cycle would go from 0 to 2 pi, and that would be the what we call the period. So here's the graph of one cycle of sine from 0 to 2 pi, and it has what we call a period of 2 pi because that's how long it takes for one cycle to complete itself. So here are some specifics about the graphs of sine that we want to look for. It begins at a point midway between the max and min. It rises to its maximum value, then falls to the minimum value, and returns to the beginning point. So those specific things happen with it. Okay? And then every cycle repeats that same pattern. Right? Starts in the middle, rises, falls, and then back to where it started. Cosine starts at the max, falls to the minimum, and then returns back up there again. And then it repeats that same pattern over and over again. Okay? So we're going to talk about this thing called period, and period is how long it takes for it to repeat itself. Okay? So for sine and cosine, the standard is sine and cosine functions, their period is 2 pi because they repeat themselves every 2 pi units. All right, so we're going to do a little graph exercise here. So before proceeding to the discussion about functions that have different periods, it would be helpful to consider the functions of this form. So here we have sine of bt and cosine of bt. All right? B is used in our big equation, right? Okay, and it's the same value of B we're talking about there. And what we're going to look at is how when B changes, the period changes. So I want you to put the cosine of 4t in your calculator with a viewing window from 0 to 2 pi. Okay, so we're going to start just with cosine of 4t. Make sure your mode is in radians. And make your window from 0 to 2 pi. And you can go from negative 4 to 4 would be fine for your y. So how many cycles are there then between 0 and 2 pi? How many times does it repeat itself? So how many times, let's see if I can, oh, I don't think I'll do that in the marker. Okay, how many times does it repeat itself? So it starts here. Ooh, there's 1, 2, 3, and 4. Okay, so it repeats itself 4 times. So what number did we put in there for B? 4, right? Okay. All right, good, John. Okay, all right, now, so let's try, so do the sine of 5t then. So since sine starts in the middle, and it goes up, down, and back to that starting point once, twice, 3 times, 4 times, and 5 times. And another way you can look at it is just look at how many, what are there? Okay? How many max points are there? Or how many min points are there? Okay? That will help you to see that too. So we have, yes? Well, that tells you how many cycles there are. Okay? All right. But now we're going to talk about how they want us to determine the number of cycles. So we did that. And then find the period or length of one cycle. Okay? So we're going to talk about the length of one cycle now. Okay? So what is the length of one cycle then? For cosine of 4t, if there's 4 cycles in 2 pi, how long is each cycle? Okay, and how would you get pi over 2? Okay, we had a length of 2 pi, and we divided by 4. And so the period here was pi over 2. 2 pi divided by 4. Okay? And then for the sine of 5t, okay, what would be the period for that then? Okay. We had 5 cycles in a period of 2 pi. So to find the actual period, which is, this represents the length of each period. Okay? So now, let's do something. Let's go back. Since we said the period for that one was 2 pi over 5, go to your window, and let's make sure I'm using the right tools here. All right, go back to your window, right, and change your x max to 2 pi divided by 5. Right? So then that should produce one cycle, right? So let's see what happens with the graph. All right, goes up, goes down, and back to the starting point. Okay? So here's our first formulas for this lesson then. That if b is greater than 0, then the graph of either sine of bt or cosine of bt makes b cycles between 0 and 2 pi, and each one has a period of 2 pi. Divided by 5, or divided by b, excuse me. All right? So there's b represents how many cycles there are between 0 and 2 pi, and then the period is 2 pi divided by b. But remember, what are we really talking about with the value of b? B is a horizontal stretch or compression, because it's a change in the x value or the domain, okay? Right? The dependent or the independent variable. Right? So number 1 says determine the period of each function. Well, to find the period, we take 2 pi and divide by b. And so what's the value of b for a is, okay, 2 pi over 5. And for letter b, that means we're doing 2 pi divided by, what's the value of b there when it says t over 3? 1/3, okay? So dividing by 1/3 is the same as what? Multiplying by 3, so it's 6 pi. Okay? So let's take a look at that graph. So it says the period is 6 pi. That means that I need to go from 0 to 6 pi if I want to see one cycle. Right? So if we put in So if we go to our y equals and put in the sign of x divided by 3, that means we're going to have to go from 0 to 6 pi so I can see one cycle. Okay. So is that a stretch or compression? Stretch, okay. So if the number is larger than 1, it's a compression. So this means I would be compressing it by 1/5, which means then each cycle is 2 pi over 5. And t over 3 means I'm stretching it out. And the reciprocal of 1/3 is 3, so I'm stretching it out 3 times longer, which means then I have to multiply 3 times 2 pi to find the period. Okay. Now here's this caution down here. It says the calculator may not produce an accurate graph for large values of b. So go ahead and type in sine of 50t and change your window back from 0 to 2 pi. And sometimes you get some really cool patterns because, let's think about it for a second. What does that 50 mean? Okay, we're compressing it by 50, which means that each cycle, or how many cycles are there in that space there? Well, there's 50 of them, right? That means in this little area right here, that this graph is going to go like that 50 times. Okay? So just imagine taking it and squishing it together. So how long is each period here? What's the period here? What's it equal? Okay, okay, it's 2 pi over 50, right? Or pi over 25. Okay, that's a pretty small number, isn't it? Let's see if I really put that number in. So if I do pi divided by 25, that's how long each period is 0.1256. So if I change my window, change this to pi divided by 25, now I can see one cycle. Okay? So that is definitely compressed, okay, by 1/50. All right? Okay, so let's talk about tangent now. Right? Now, if you remember, if you looked at the graphs of tangent, tangent was a little different, wasn't it? Okay, so if we look at tangent, now they're talking about a viewing window from negative pi over 2 to pi over 2. So how long is that? How far is it from negative pi over 2 to pi over 2? Let's see. How far is it from negative 1/2 to 1/2? Okay, or pi, right? Okay. So we're talking about a length of pi here. So tangent repeats itself. For this one here, it repeats itself 3 times, right? One of those days. Okay. So this one repeats itself 3 times. This one repeats itself 4 times, but in a period of just pi. So for tangent, then, to find the period, we just do pi divided by b instead of 2 pi. because the period, the normal period for the parent function for tangent is just a length of pi, so we're only using pi divided by b instead of 2 pi. Okay? So for sine and cosine, secant and cosecant, okay, it would be 2 pi divided by b. For tangent or cotangent, it would be pi divided by b to find the period. So for letter A here, the period would be pi over 5. For letter B, pi divided by, and the value of b in this case is 1/2. So we multiply by 2 and we get 2 pi. Okay. So is A a stretch or a compression? Okay, it's a compression by 1/5, and B is a stretch then by 2 because we doubled it. Okay, remember that. Those are always the reciprocal when we're talking about a stretch or compression horizontally. Okay, all right. Now, there's this thing called amplitude, right? And all the amplitude is the value of C. Okay? The absolute value of C. Now they're gonna use the letter A here because we're gonna change it up just a little bit. But in reality, it's just gonna be the value of C when we have our expanded form. Okay? When I talk about our expanded form, I mean we're talking about C times f of b times, oops, what did I do? I messed that up, didn't I? That was A. Should be f of A times x minus b plus d. Okay. All right, that's our standard form we've looked at, right? Okay. All right, I wrote that correctly, didn't I? Okay. And so basically we're talking about the letter C, but when they do it here, they're going to use A down here. Right? So all the amplitude is our vertical stretch or compression. Okay? Whatever that number is. Okay? So here, first of all, they want us to, we're going to do some graphing. So we're going to do some vertical and horizontal stretches and compressions with graphing. So they want us to graph 4 cosine of 5t. Now, it doesn't say how much, does it? So we're going to graph one cycle. Okay? Or actually, we'll go from 2 ways. So how long is one cycle for this graph, for A? How long is one cycle? No, it's not pi. Okay. We can find the period. One cycle is the period. So the period here is 2 pi over 5. So that means I'm going to do this. All right, we're going to go, and what does the 4 tell us? Okay. That's a vertical stretch, right? So that means the maximum value is going to be 4, and the min is going to be -4, right? So we're going to go up here to 4, down to -4. And now since our period is 2 pi, I'm going to put 2 pi over 5. I'm going to put 2 pi over 5 and -2 pi over 5 in my last values. Because that's how long one cycle is, right? Okay. So what is half of 2 pi over 5? Is that pi over 5? Half of 2/5 is 1/5? Okay. Remember, that's one of the things you can do is just, I can think of it, okay, let me get that pi out of the way and just think about that fraction. Half of 2/5 is 1/5. Okay. So then this spot right here is going to be pi over 5. Okay. That makes sense, doesn't it? Okay. If I'm at 2 pi over 5 here, then I'm at pi over 5 here. Well, then what about the this increment here. What's that going to be then? That is half of pi over 5, right? Okay, what's half of 1/5? 1/10, is that right? If I take 1/5 and multiply it by 1/2, right? Okay, that would be 1/10. So here's what I expect with your graphing. Okay, I expect you'll be graphing normally one cycle. Okay, and then I expect you to label these 4 spots here. So I have pi over 10. So I have 1/10, 2/10, right? So the next one would be 3/10, so 3 pi over 10. And then 2 pi over 5 would be 4/10. Okay? And I just graph cosine. Max, 0, min, 0, max. And then go the other way. And there we go. Okay? So we just graph that function. Right? We only graph one of them, which is okay, one cycle, or we did 2 cycles actually. Okay? So to be able to graph them, what I need to do is when I graph one cycle, figure out what the period is. Okay? So let's look at letter B here, 1/2 sine of t divided by 3. And what I want you to do first is draw the graph of sine. We're just going to first draw the graph of sine. Sine starts at 0, right? Okay, and it goes up to 1, 0, -1, back to 0. Okay. So I'm going to go up to 1. I'm going to use now notice I didn't put any numbers on there yet, have I? Okay, is that the graph of sine? Okay, it is, right? Okay, I have no numbers. All right, now, how high is it going to go and how far down is it going to go? What's our vertical information? 1/2, right? Because this is going to be compressed by 1/2. So I'm going up to positive 1/2 and down to negative 1/2. Right, that's where my max and mins are now. Okay, and what's the period in this case? Okay. To find the period, we're going to do 2 pi divided by 1/3, right? Because that's the value of b. So the period is 6 pi. So then down here, this is going to be 6 pi. Okay. Our y-axis is always 0. Okay. So that'll never change. So what's half of 6 pi? Okay. So then this spot right here where this 0 is at is going to be at 3 pi. What's half of 3? Okay, or 3 over 2, right? Half of 3 is 3/2. Okay, so this is 3 pi over 2. So I have 3/2. This would be 6/2, right? So then this third spot here would be 9/2. So this would be 9 pi over 2. I know it. Okay, right. And there we graphed it. Okay, we graphed one cycle of that. So what I will do is when I'm drawing graphs, make the graph, whether it's sine, cosine, tangent, whatever, figure out the length of the period, make that my max value on the horizontal, okay, cut it in fourths, figure out what the vertical axis is by using the whatever the value of C is. Okay. All right, so then we're just going to focus on what we call amplitude and period. Okay? The amplitude is whatever the stretch or compression is vertically. The period is whatever the stretch or compression is horizontally. Okay? So amplitude is my vertical stretch or compression. And my period involves the horizontal stretch and compression. So if you notice here, for amplitude, they use absolute value of A. What does that mean? Okay, it's always positive. Okay, amplitude can't be negative. Doesn't matter whether the value of A is negative or not. The amplitude is a positive number. Okay? And the period is always going to be a positive number. So here we go. For this one, it says, is this one on your paper? Okay. It says determine the amplitude and period of -3 sine of 2t. And so what's the amplitude? All right, so the amplitude equals +3. There's always a positive number. And then the period is going to be what? So the period is always, since it's sine, that's 2 pi divided by b, or 2 pi divided by 2, or pi. Now this one gets a little bit more specific. They want us to graph it on an interval from -pi to pi. Okay, so here's -pi here, here's pi down here. Okay. What's the period for this function? Pi. Okay, so we're good, right? That's going to be, so we're going to have one cycle on the left and one cycle on the right. Okay, so this is pi over 2 here, and -pi over 2. Let's just do those. Okay. All right, before we do anything else, I want you to graph this on your calculator. Okay, exactly what they have there. Put the function in, and from -pi to pi. Okay, here's our normal graph of sine. I wrote it up here on the board. Okay. There's a normal graph for sine. Okay. At 0, okay, what's the sign of 0? 0. And if I multiply 0 times -3, what do I get? 0. Okay, so at the origin here, we still have 0. Now, at the first max value, which is our first quadrant, right? The end of the first quadrant. This is normally pi over 2, right? Okay. But in this case, it's going to be here, which actually is represented by pi over 4. Okay. So what's negative 3 times 1? Okay, so at pi over 4 then it's going to be at negative 3. Does it matter which increment I use here? No. All right, I'll put it down here. Okay, so I go by ones. Totally up to you. So then that tells me that this is going to be negative 3 here, and this is positive 3 up here. Okay. Now at the next spot, right here, sign is 0. All right, so what's 0 times negative 3? 0. So at pi over 2 then, which would be our next. Okay. All right. Then we're at negative 1. What's negative 1 times negative 3? Okay, so we go up to 3. All right, and then we're going to go back down to 0, and we can follow that pattern. And there's our graph. Now it looks just like what's on your calculator, right? Okay. Now, so we have here, what do we graph? Negative 3 sine of 2x. Okay. And from negative pi to, negative pi to pi. All right, there's our graph. Now, okay, if I hit trace, all right, we have 0, 0. Okay, we're good there. All right. If I hit pi, okay, there we are, 0. Okay. What's half of pi? Pi over 2. So if I go to pi over 2, using my trace, hey, there I am. I'm still at 0. Okay. So what's half of pi over 2? So if I do pi divided by 4 then with my trace, there we are at negative 3. Okay. So I could transform those numbers also if I needed to. Okay. And that's why here's one of the things you might want to do is that when I go to do my table, so if I go to my table setup, if I start at negative pi, okay, and since the period is pi, I'm going to divide the period into fourths. Okay, right? Isn't that what I did here? Divide into fourths. We've always divided into fourths, okay? So pi divided by 4 would be my increment I go by. So if I change of table here, if I make that pi divided by 4, that means it's going to match what I have in my graph. And so if I go to my table, here's all my numbers. 0, negative 3, 0, 3, 0, negative 3, 0. Negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0. Pi over 4, pi over 2, 3 pi over 4, and pi. Okay? So you actually can use your calculator to help you with those instances also.